All right, last section before the midterm. We will go over a review on Thursday. I'll go over the midterm review that's in my math lab. It changes question or numbers and sometimes the questions a little bit for you guys. But I'm gonna walk through it. If you can, try to do it on your own before then once. You can do the midterm review as many times as you want. If you try to do it before you come in on Thursday, you'll know exactly what you understand and what you don't understand. And you'll be better off on Thursday. Today we're doing chapter 7. Chapter 7 is on continuous distributions. Rather than discrete distributions that we were doing in chapter 6. And this means we want everything should look like a normal bell curve. This is what happens when we get continuous distributions. Ends up this way. And so. What you're gonna need to know is stats, calculators, normal for StatCrunch. And you've seen this shape. This is the shape we were using a lot. Where you have mu in the middle. And we went out one deviation each direction. And we could do it 3 times. This was the design on the empirical rule bell chart. And previously we were doing 68% between these two. 95% between 2 deviations. And 99.7 between 3 deviations. That's for the empirical rule model. These were not accurate. They're close. They're really close. They were done for easy calculation. We're gonna actually do the real model and take a look at how it works. So some things to know about this normal distribution. It's called the normal distribution. It's like above, it's symmetrical about the mean. The area under the curve equals 1. The number line increases from left to right. Number line below increases from left to right. And the graph never touches that line. for a given area under the curve. Like, let's say we're looking at the red region. Say between two values. Sometimes the values is infinity, but we can pick two values on the table and just do a region within. I could very just as easily do a region in green like this. And only does that range and use those two values instead. For a given area in the curve, we can say that it represents. One, the proportion of the population with the trait. Yeah, remember, population doesn't necessarily have to mean people. It often is, because people will give you answers back if you ask them. Or B. Not B, two. The probability that a randomly selected person. Or I'll say individual, since it doesn't have to be people. From the population. Possesses the trait. Alright. Anyone need this page up longer? I don't see anyone still writing, so I'm gonna guess no. So like, for example, let's just look at what that means on our IQ test that we did. IQ test, the mean was 100. And the standard deviation was 15. We looked at this many times. And so if we looked at the range of scores. From 85 to 130. This was the same as looking at -1 standard deviation up to +2 standard deviations. And the area yielded for something like this would have been 0.815 or 81.5%. And again, this is from the empirical rule, which we're moving away from. We'll look at it in a little bit more detail here. But to get the idea of where I was going with this is, so this says 81.5% of the population has a score, as an IQ between 85 and 130. That's one interpretation. And if I select an individual at random from the population. There is an 81.5% chance or probability that their IQ lies in that range. So we're gonna go check out what the actual values are using StatCrunch. For plus or minus one deviation, plus or minus two deviations, plus or minus two deviations. It's important to know in the normal calculator. The probability that X equals a specific value is 0. On a continuous distribution, you're looking at the area underneath it, and if we don't have an area, like there's no start and stop, we have like a rectangle that's a certain height but 0 width. So there is no equal sign on the list. Which means if you want to say greater than or equal to, you just have to use greater than. And if you want to use less than or equal to, you got to use less than. I think they do it the other way around. I actually think they include the equal sign because it adds 0 to it. But these two are going to be equivalent, so whichever one shows up on the list, we'll find out in a second. So using the IQ score. Let's check out our real percentages. We had plus or minus one deviation equaled 68%. Plus or minus two deviations was 95%. And plus or minus three deviations was 99.7%. That was the empirical rule. Find out what they are in the normal calculator. And with those values, like doing plus or minus, this is, remember we're doing 115 So this will be a range of 85 to 115. This will be a range of 70 to 130. And this will be a range of 55 to 145. Those are the numbers we're gonna have to use when we're looking. Good, ready? Almost, and we're still ready. Don't stop because I said your name. Are you done? You done? Anyone else need longer before I switch over? Alright. And I need to change on this as well. And we go stats, calculators, normal. We're gonna put in our mean is 100. And our standard deviation is 15. Looks like they included the equal sign, not the other one. We're gonna click on between up here so that we can go between two ranges. You have the option of standard or between. In fact, I'm gonna point out something real quick. Before I change these numbers from 0 and 1, I only had standard in between. As soon as I changed these numbers and clicked a button, these showed up. Those are the values from the empirical rule. So we can make it, if you click on that, it makes the value on the bottom. Rather than doing whatever the hell I wanted, doing every 20 year, it makes it line up with the empirical rule. Which is handy. We wanna look at, we said 85 to 115. Is plus or minus 1 deviation. And notice that it's point. If I did 4, it would be 0.6827 or 68.27%. I'm gonna write that down next to 1 deviation. See it in a second if you write something, or if you don't right now. If we look at 2 deviations. This was 95% on the empirical rule. That's what it looks like there. But the actual value would be 95.45%. And if we do 3 deviations. It's close to the 99.7%, it's actually 99.73. And we're gonna do more with this calculator in a second. Let me switch back over to our screen. So I filled in the values there. Notice they are close. To the empirical rule. But they are more accurate. In real life. We use the empirical rule for a quick check that doesn't need a table. Or. Whole number deviations. Away from the mean. This corresponds with what we're gonna do in 7.2 when we look at the z-score. This is when z is plus or minus 1, plus or minus 2, plus or minus 3 in the next section, which is gonna be in short way. And generally, that's for an approximation. If you were doing a scientific paper, you would not use the empirical rule. If you did, you would say this is from the empirical rule, so it's close, but not quite. You wanna see the formula that goes with this that you're avoiding? You thought the Poisson formula was fucked up. The formula that. Stats majors use. Like if you're gonna go into statistics, you gotta go to the calculus route. 1 over the standard deviation times the square root of 2 pi. And then we have E times E. To the negative 1/2. X minus mu over sigma squared as an exponent. It's fucked up, it's dirty. When mu equals 0 and sigma equals 1, it actually gets a lot prettier. It's 1 over the square root of 2 pi. E to the negative 1/2 x squared. But you're not having to work with either. And we'll learn about this one in 7.2. But I want to do one more problem, do a problem in here. Let's say the weight of giraffes. Is normally distributed. With a mean of 2,200 pounds. And a standard deviation of 200. So let's do a couple things with this. Let's sketch the graph. Of the empirical rule setup. Should be able to do this. So what do we put in the middle? 2200. Now what should I do? God, I wish that looked a little bit more like the middle. So 2400 would be this one, that's plus 200 pounds or 1 deviation. And Alfredo's on the right track, we're gonna keep doing that. What else? You guys gonna make Alfredo do all the work, aren't you? Minus 200 or minus 1 deviate, that's a lie.
Forget all this after, but. You just go back to reality.
Back to reality, how dare you, sir? Statistics is in reality all the time. You see are seeing statistics daily this semester.
I did go back home still thinking about this, it's in my nightmares, but.
Harris leads Trump, Trump leads Harris. What are the percentages? They're doing statistics right there. You see this shit daily.
Yeah, that was kind of weird, we were talking about the hurricanes and then they like popped up on the news, I was like.
Right?
I was like. What are the.
We summoned it. That's what we did. Alright, so that's the sketch, that's what we wanna do. Next thing we're gonna do is. Shade the area. For a giraffe. Weighing. 1,700 pounds or more. So what should I do now? Inmar.
Shade the area between. 1600 and 1800.
Just the whole area, 1,600 to 1,800?
Oh, there you go, cause you have to shade that is 17.
So where's 1,700?
In between.
About halfway, right? Alright, now it says weighing 1,700 pounds or more. Where should I shade?
Um,
To the right. Yeah, the way you said it initially was shading between 1,600 and 1,800. So I wanna make sure that's not what you meant. And maybe I shouldn't have done that, cause now I'm shading a lot.
yeah.
What does the shaded area represent? Maybe we should go get a percentage real quick first before we continue with that idea. So I'm gonna bounce over to over here. Stats, calculator is normal. I'll put in my 2,200. I'll put in my 200. And I'll say greater than 1,700. 0.9938. Let's just do 0.994. How about that? So 0.994. I'll go back over to what we're looking at. So we saw this is 0.994 or 99.4%. So what does that shaded area represent? It's the A or 1 proportion of the population. Proportion of giraffes. That weigh more than 1,700 pounds. Use LBS for pounds. That's its abbreviation. I don't know why, there's neither an L nor a B in pound. Usually we pick at least one of the fucking letters and try to aim for the letters in the front.
Maybe it's that.
Mine, so I think they use kilogram, I think they use have metric also, I don't know. I don't know, Latin, like, when Latin was the real language, not like Latin-based languages, but the Latin was the language. Did they use the metric system back then? I don't know, that's a interesting question for a historian. It's also the probability of randomly selecting a giraffe that weighs that much. Weighing 1,700 or more pounds. Yes,
I googled it and it is Latin. It's Latin for Libra, for balance.
Is that a guess or who was a guess?
good guess.
What's the probability of that?
That you guessed correctly.
Get out here.
I don't know, why don't you calculate it? Alfredo's test question is calculating the probability that he would have guessed that.
51%, right or wrong?
There you go, 100%. You got it right. It's a test guy. You wish. Alright, so that seems like that's a large percentage. 1,700 pounds is a lot though, I'm like, fuck, that's like, there's cars that weigh less than that. So in giraffes, they're big, but they're fucking narrow, they got thin legs and shit, but. I guess when you get to that body, that long neck, that adds up. It's not that thin, it's thin enough, but it only really looks thin because it's really long. It's like thicker than like a human leg. So that's like, you know, you got a long neck like that, it seems like a lot. But like. Is it a lot compared to like maybe a hippopotamus or a? Hippopotamus is short and stout and round. How's it compared to a hippopotamus? Do we need that longer? Alright. So if we wanted to compare to a hippopotamus. And I have no idea what the mean and standard deviation of a hippo is. It's like apples and oranges, but we had a tool for this. We would use Z-score. And we calculated this before. It stems from the idea that the individual, oops. The individual. Score. Is equal to the mean. Plus Z standard deviations. And if you solve this for Z, you get. Z equals X minus mu. Over sigma. And this was in that formula. In the exponent. Let's figure out that giraffe though. The Z-score of the 1,700-pound giraffe. We're doing 1,700. Minus the mean, which was 2,200. Over the standard deviation, which was 200. That's negative 500 over 200, which is negative 2.5. So it has a really low Z-score. So this kind of leads into 7.2. Is the standard normal distribution. Once something has been Z-scored. They'll say that it's been Z-scored or converted to a Z-scored. It now lies on a different bell curve. That is applicable to anything that has been Z-scored. I'm gonna get rid of that 1700 under there, when we have a number underneath it, it actually means something. And it doesn't mean what I wrote. On the Z-score distribution though, on this, and this is called the standard normal distribution. This new bell curve is the standard normal distribution. Which means it's gotta have the same setup, it's gotta have a mean and standard deviation. The mean equals 0. And the standard deviation equals 1. And you'll note these are the default settings in StatCrunch. Or the normal calculator in StatCrunch. So. And the reason why I just scribbled out this number up here. If you see Z with a number, like I had. It's really prompting you to find the probability that Z is less than that number. So like. Z 0.7 is the probability that Z is less than 0.7. I think I'm gonna add a little bit more to this thing, this comment here, default settings for the normal calculator in StatCrunch. It doesn't say Z though. It still says X. So you're just gonna have to deal with that. You have to know if it's 0 and 1, it's Z and not X. And then if they have something with Jesus fish. Z alpha. That's the letter alpha in the Greek language, but a lot of people call it Jesus fish. Cause with all the, you see it on cars and shit all the time. I don't know why. It's just not. I don't know where that came from, but. And they'll generally have like a number there. That's for when it's greater than. This is actually the easier spot to see how those plus or minus deviations work too. We're gonna do a bunch of examples. In StatCrunch. You gotta know how to use this calculator because it shows up a lot. So maybe we'll do Z is greater than 1.5. B Z is less than 1.2. C. Negative 0.7 is less than Z less than 2.1. And of course, I could, to make it look like StatCrunch. Put a P around this. We'll do -1 is less than Z is less than 1. -2 is less than Z is less than 2. -3 is less than Z is less than 3. Switch over and look at it, and we'll do these, and then we'll take a short break. Go through some examples, and we'll probably be done by 5:30. And as long as we take like a 10-minute break and not like a 15-minute break. Y'all ready to take a look at it? So when it starts off the way you want, all you gotta do is start changing the shit down below. If we want greater than 1.5. We just change this stuff. We're looking at this value here. I'll write in, I'll do 4 decimal places. Homework does that a lot. And then the next one we wanted to look at was less than 1.2. So we'll change that to say less than, and we'll do 1.2 here. Notice you can always look at the graph and make sure it's shaded correctly, as long as you understand what less than and greater than means. This would be 0.8849. And then we'll go to between. And change these, I said negative. Oh, we had -1 to 1 on the list. They've already given me the numbers, let's put it down right now. This is D on my list, not the one I started with, but. It's already there, no need to put it back in again. So 0.6827. Now we'll go look at the weird one, -0.7. Up to 2.1. 0.7402. We'll take a look at -2 to 2. .9545. And -3 to 3. Is 0.9973. Alright, you'll notice. These last 3 were the same values from the empirical rule. That we did. With the IQ test. Check, you'll see you get the same values. So this is the easier way to find out what those actually are. And that's why we approximate with 68%, 95%, 99.7. It's not a perfect match. But it's close enough. Alright, let's take like a 10-minute break. I'll pause the video. Okay, let's look at some more examples. Ralph, before we do, let's talk about what you would do in real life. So in real life, when you're given these weird things. That are not. Standard normal. As in mean equals 0, standard deviation equals 1. The old way, and some still used by many. Is convert to z-scores. And then use the z-score tables. Or a z-score calculator with a computer. But oftentimes nowadays. Often you can just enter in. The mean. And standard deviation. And do a calculator. And not worry about z-scores. But if you do that, you lose one of the great things about it. Is the great thing about z-scores. Is its ability to compare things in other categories. Or between different populations. When we did it early in the semester, we had guys and girls comparing height. Cause it's not fair to generally compare the two, cause guys have an average that is taller. Than females. Assuming a binary gender system. So. Patient stated, people are writing. Alright, so let's look at a few examples. GRE scores. Are reported as percentiles. Find the Z-score of the 88th percentile. Someone in the 88th percentile. Well, we can do this in the normal calculator. In the past, we've been filling in the Z-score part though. Here, we wanna do the percentile part as 88%. What was percentile? Was it less than or greater than? What did percentile mean? So percentile, this would be someone who scored higher than 88% of the population. What? You'd wanna think that. But if we do greater than or equal to. Greater than or equal to would shade over here. And is that saying that it's higher than the 88%? Actually, no. We want this side. So like you're here, 88th percentile. And 88% of people are lower. So there's two ways to look at it. From the person that got it, you're higher than 88%. Another way to look at it is 88% of the population scored lower. Just depends on which perspective you're looking for. So we're gonna go for lower than. And we will shift over to StatCrunch and take a look at it. So we're using the normal calculator. I'll open it again, just so you get used to seeing its path. Stats, calculator is normal. We're gonna set that equal to 88%. And we're gonna leave it as lower than. So Z-score to 3 decimal places would be 1.175. Alright, switch back. I wish this was easier to switch back than have to try to do it on both at the same time. Alright, another example, gestation period of human pregnancies. It's kind of like, how long are you pregnant? Prego. These tend to change as time goes on, but not by a lot. The average is 266 days with a standard deviation of 16 days. Nine 30-month days. Or 30-day months. Would be 270. So that's why you hear that. They tend to be pregnant around 9 months. Cause no one's gonna say 8 months and 3 weeks. And fucking 3 days. Some shit like that. What percent are more than 270 days? What percent of pregnancies are more than 270 days? What percentage are very preterm? Which means less than 7.5 months. Or 224 days. We'll take a look at these in the calculator in a second. And finally, what gestation period captures the inner 90%? Rounded to the nearest day. Quit fucking calling me about politicians. Someone called the other day and like, what do you know about Rudy Salas and David Valadeo? And I'm like, I haven't looked much into who I'm going for locally. This election, they're like, locally, those are your, it's gonna be your next US congressman. I'm like, yeah. But they represent my local district. I've been following what's going on with Trump and Harris. But it's not election time yet, you know, I've got a month and a half to fucking, or, you know, a month and a week to decide who I'm gonna vote for locally. Good times. Alright, that gave you time to write this down. Let's pop over. And knowing the stats, calculator is normal. We're gonna throw in our information, which was 266 and 16. Because fuck taking the time to convert to Z-scores on each of those things, just to figure out what I want. And we wanted the percent of pregnancies more than 270 days. If you're not sure if you've got the right symbol. Just click compute and see if that represents more. You can see the days it's looking at by looking at the color and the region. This is looking at days that are less than 270. So I wanna change it to that one. And this is looking at 40.13%. What percent are very preterm was less than 224? We'll change that to less than and we'll put in 224. And that sure doesn't look like very many, less than 1%. I went home and this weekend I played Pass the Pigs, never played it. I've used them as a teaching tool for fucking 6 years. Never played it, but my wife's been playing Yahtzee with her fucking, one of her cousins, like once a month or so. Like, you might enjoy this, but we went to some friend's house and like. I wanted 15-20 minutes to burn, it was actually surprisingly fucking fun. When you have to play by the rules, not just like using it to calculate probability, it's pretty fun. That was fun waste of your time. Me telling you that. What gestation period captures the inner 90%? We wanna do between. We're gonna change this to say 0.90. And if I round this to 1 decimal, which is where I'm gonna start. 239.7 to 292.3. If I round correctly, because it says round to the nearest day. What would be the nearest day here?
240.
240. And what would be the nearest day on the right one? If we look at 240 to 292 though. Now we don't have 90%. So I'm gonna show you what's happening pictorially. We have that number line over here, we had like the 239.7 and the 292.3. And if we go to 240. 240 is here. And if we round into 292, we're going there. This was the inner 90%. But we don't have that full range. We have less than it. So what you wanna do when you have questions like this to do it and get it correctly. It's gonna sound weird, but you wanna like round outwards or round where it still gets that value. So rather than rounding how we should. Following rounding rules. I wanna make sure I get this full value. I need this whole range. So I would go to get it and get it still a whole day. I would go down to 239, even though that's not the correct way around. I still capture that 90% that way. And here I would go up to 293. Which is getting more area, but at least it gets the inner 90% and meets the criteria. So the correct answer here would be 239 to 293. Despite rounding the wrong way on both. They'll do that every once in a while on the homework, so you gotta pay attention to it. If what you did says no, see if it was something like it only happens when they give you a percent target. And you're calculating the actual like X's or Z's. So if they give you the percent and you got it wrong, double check to see, go like try rounding the other way. And see what happens. Alright, that kind of hits chapter 7. We will go over the midterm review on Thursday, take a swing at it before then. I think there's more questions on the review than the actual midterm, I'm pretty sure I set that way. That way you like. Testing you on less questions, but making sure you practice everything that you should be practicing. It's not a whole lot less question, it's not like 38 drops down to 10, it's like 30 down to 30 or some shit like that, I don't know. But there's a few less questions on the actual midterm. You won't know which ones, so you should probably try to know how to get them on. If I got GTFO or stay and ask questions.
Want to stay here?
If you want to stay here, I'll stay here. If he doesn't want to stay here and everybody leaves, I'm getting drug out too.
Want to talk about that baby, if the internet,
What can you get,
I don't know, this is what it was born in Asia. The pipes that you keep from the store,
No shit.
told my wife, I want to hit one.
You want a hippopotamus for Christmas?
Yeah, maybe I can.
Only hippopotamus
answer
for
that
zoo?
question. Eat that song.
My wife loves that song.